Alrighty, today we are going to be looking at another type of two-variable system, this time being linear and absolute values. So the way that we do this is first rewrite each function in y equals form. So y equals 4x plus 9 is what I would rewrite that first one as. And now I can set them equal to each other. So I've got that absolute value of 5x plus 9 equals 4x plus 9. My absolute value is by itself, so I can set up each of my algebraic equations to solve for. So 5x plus 9 equals 4x plus 9, and 5x plus 9 equals negative of 4x plus 9. So starting with this one, I'm going to move all my x's together, move all of my constants together, and I get that x equals 0. On the other one, I have to first distribute the negative. So 5x plus 9 equals negative 4x minus 9. I'm going to get all my x's together, get all my constants together, and I get that 9x equals negative 18, which means x equals negative 2. So before I find my corresponding y values, I first need to check for extraneous solutions. So I'm first going to plug in 0 to my equation that I solved. So that's going to be 0 plus 9 inside my absolute value equals 0 plus 9. The absolute value of 9 is 9. That one works. Now if I do negative 2, it's going to be negative 10 plus 9 inside my absolute value equals negative 8 plus 9. The absolute value of negative 1 is 1. So both of my solutions work. I've got two x values. What I have to do now is figure out what is the y value for that. So if I plug in 0 to either equation, my y output is going to be 4 times 0 plus 9. That's going to be 9. So you've got 0, 9. And then for negative 2, negative 8 plus 9 equals 1, negative 2, 1. Those are your two solutions. Okay. Let's do this again. On to the second one. Absolute value of 2x minus 8 plus 10 and 4x. So if I rewrite this in y equals notation, I can now set it equal to 4x and my absolute value is not by itself, so I'm going to have to subtract the 10 and say that 4x minus 10 equals the absolute value of 2x minus 8. Now I can set up my two equations. So 2x minus 8 will be equal to 4x minus 10, and 2x minus 8 will be equal to the negative of 4x minus 10. So to solve this one, I'm going to get all my x's and all my constants together. And I get that x is 1. I have to distribute the negative for my other equation. And then again, do some rearranging. So I've got two potential solutions, 1 and 3. I've got to plug them both in here to make sure they're not extraneous. Let's start with 1. It's going to be 4 minus 10 equals the absolute value of 2 minus 8. So negative 6 equals the absolute value of negative 6. That does not work, so this solution is extraneous. Now let's try 3. 12 minus 10 equals the absolute value of 6 minus 8. The absolute value of negative 2 is 2. So 3 does work. Now I need to find my y coordinate. I'm just going to plug it into the second one because it's a little less math. And I get 12. So 3, 12 is the solution. Okay, one final example. Again, I'm first going to rewrite this in y equals notation. And now I can set these equal to each other. Need to get my absolute value by itself. Now I can solve this. 4x minus 7 equals 3x minus 7, and 4x minus 7 equals negative of 3x minus 7. More algebra stuff. X equals 0. Then over here, when I distribute my negative, I get negative 3x plus 7. And I get that 7x equals 14. So x is 2. So 0 and 2, let's see if they are extraneous. I'm going to plug them in here. 0 minus 7 inside of my absolute value equals 0 minus 7. Well, the absolute value of negative 7 is not negative 7, so this one is extraneous. Let's try 2. 8 minus 7 inside my absolute value equals 6 minus 7. The absolute value of 1 equals negative 1. That one is also extraneous. So this one has no solution.